is uppercase. So we have this function, which we want to take the antiderivative of. We've got to make sure that when we do that, the result will be the number 2 when x is 0. That's what we've got to do. So the first thing you do is take the antiderivative like we did before. I'll take the antiderivative of secant x tan x. You guys know the answer. What is it? Secant. So we have secant x, and now I've got to write what? Plus c, right? This gives us what's called a family of functions, because the c can be anything, right? So it's a family of curves. But once you declare that you know something about this, right? Right now, this is f of x. This is capital F, sorry. This is capital F of x. That's the result. Once you have that, well, if this is supposed to be 2 when x is 0, so now I just plug in the numbers. F of 0 is secant of 0 plus c. That has to equal 2. F of 0 has to be 2. So c is 1. Secant 0 is 1. 1 plus something is 2. And I know that one from a long time ago. It is 1, right? So Samriti had it right. C is 1. So now what's our function? The function, which is the antiderivative of this and also follows this condition, is the particular function. Called particular function. What?
Secant x plus 1.
Secant x plus 1.
All right, so you're saying if that's the regular function, the capital is just...
It's the antiderivative.
Okay.
The capital is the antiderivative in this notation. So it's the same as the problem you did before. You were finding the family of antiderivatives. You're finding all antiderivatives. The plus c is all of them, right? All this c does is move the curve up or down, right? When you add a constant to a function, what does it do? Vertical shift, right? So that's why the derivatives of this, even with the c, are all the same. They're all secant x tan x. Because when you move something up and down, does not change the slope of the curve anywhere, right? Moving something up and down doesn't do that. Agreed? Davis agrees with me on this. All right, good. So we have this family of curves which satisfy the antiderivative of this, right? That all of its slopes are secant x tan x. But now they give you this extra condition, so that's where it differs from the problem before. It's an extra step. You're going to plug in 0 into the function you just attained, and make sure it equals 2. Find the c that makes that happen, and the problem's over. Another one like that. There we go. 45. Quite similar. This time, they actually write the original as a derivative. This is called an initial value problem. But it's the same thing you just did, with a difference. So what is it, 45? So they write g prime. You know the derivative of something. You want to go back to the original. It's the same thing you just did here. They just didn't write it as a prime. Right? There was a lowercase, and you found the corresponding uppercase antiderivative. Now they give you the prime notation. The derivative, which you want to go backwards from, is 7x times x to the 6th minus the 7th. So that looks like a product rule. It looks like it became a product, but I don't care. I can't handle product rules right now. Right? I don't have any intuition or techniques to deal with it. So what are you going to do? You're just going to multiply that 7x through and treat it as a couple powers. Right? That's what you're going to do. The condition is g of 1 is 2. G of 1 is 2. So it's the same problem you just did. You're using a slightly different notation. They're using the prime notation to let you know it's derivative in advance. And here they're using lowercase and telling you to find antiderivative of this one. But it's the same problem. So I need to take the antiderivative of 7x, x to the 6th minus the 7th. Solve the initial value problem. It's called IVP. Simplest value problem. Solve the IVP. Solve the initial value problem. Okay? It's called an initial value problem because it gives you a derivative and it gives you this condition. This condition is called the initial value. The initial value of g, right? 1 must be the starting time or starting moment, whatever, starting point. So it's the initial value. Okay? 2 is the initial value of g at the starting point. So if they take this derivative in reverse, so I will first multiply through by the 7x. So I get antiderivative 7x to the 7th minus what? X. Yeah, I agree. There you go. I can split this into two cases. Antiderivative of 7x to the 7th dx minus antiderivative of x dx. Even if you don't write this formally, you should know that's what you're doing, right? You're going to take each one of these separately, at least in your mind. You don't have to write this step if you don't want to, right? Just like derivatives. Once you start doing polynomials, you didn't write dx next to every single term, right? You just know. You take every single term in turn, right? The same thing here. So now you can take the 7 to the outside. Again, whether you do it formally or at least conceptually, right? You don't have to write this step if you don't want to.
Would x of dx be 1?
No.
It would still be
It's going to go up a power, not down a power. Don't do derivatives, do antiderivatives.
X squared then?
X squared on,
1.5.
well, times what happened? Over 2, right?
Yeah.
X squared over 2. Got to raise the power up by 1 and then divide by the power. So this one is surely negative x squared over 2, plus c on that already. Over here I've got the 7 times, if I raise the power by 1, it goes to an 8. I'll divide by 8. So x to the 8th over 8. And there's our family of antiderivatives. Every single one of these, no matter what c would be, it doesn't matter what c is, no matter what it is, the slope of it, this whole thing, would always be that original expression we started with. So now I need to find out the particular function that we need. So g, and this is g of x, with that unknown c there, we need to find out what c is. So g of 1 is going to be 7/8 times 1 to the 8, which is 7/8, minus 1/2, 1 squared. So 7/8 minus a half, plus c, and that has to equal 2. So as you see, it's the same problem we just did. Slightly different terminology, slightly different notation. So we have 7/8 minus a half plus c equals 2. 7/8 minus a half is what? 3/8?
Yeah.
So I really need to know what 2 minus 3/8 is. And that'll be c.
2 minus 3/8.
Yep. Better hurry, I'm gonna get it. Better hurry.
Oh.
Hurry! Too late. 13/8. So now that we know the answer to that constant, due to our initial condition here, right? Initial condition. We can now put that back into here and write out what g is explicitly. Right? The particular answer to this problem, not the general antiderivative, but a particular one of them, which satisfies the initial condition as well, not just the derivative, is 7/8 x to the 8th minus x squared on 2. I've got the answer. Plus 13/8. You guys okay so far? I'm moving really fast now. Is that right though? Again, for chapter 5, you're going to become as adept at taking antiderivatives as you are right now taking derivatives. Not more so. I really want to do it, reverse it, right? Meaning, when a person drives a car backwards, it's not very efficient in comparison to driving forwards. I can tell you for sure, I drove backwards here the whole way. Just to see what would happen. It was very difficult. Very. I didn't crash at all, but it was not easy.